solving cyclic problem, okay, or any types of example of the long questions in part C. Okay, so do you need the link for Jamboard yesterday? You can. In case you didn't access the board yesterday. So for those who didn't access the board yesterday, you can scan this QR code, and if you are online, you can click on the link. Okay. So now this is where we stopped yesterday, right? We have already found our review. So just recall, how do we look for the values of internal energy? U equals to 3/2 nRT. So if it is 1, then T is equals to T1, which is 300. If it is 2, so your T has to be T2, which is 600, yeah? Okay, so once you have already completed in finding all the values of internal energy, the U values, so we can find our delta U. So delta U from 1 to 2, remember, it must always be final minus initial. So U2 minus U1, which is 7479 minus your 3740. So same goes with 2 to 3. So this one is 5672 minus your 7479. So that's why you get all your delta U values. So some will be in negative value. It's okay. Why? Because there is sign convention. Okay. So move on. Since process from 1 to 2 is isochoric, so isochoric means no work done, right? Process 2 to 3 is adiabatic, so adiabatic means no heat. Now, can we find the values of Q for 1 to 2? Yes, yeah. Because from first law of thermodynamics, delta U equals to Q minus W. So delta U 3739 equals to Q. So that's why your Q is 3739. Okay, so how about work done for 2 to 3? Same method, yeah, using first law of thermodynamics. So plug in your value 1807. Since Q equals to 0 minus W, so your work done is 1807. No? Now, how to find for 3 to 1? We do not have information. Isobaric means same pressure. Okay, isobaric means same pressure. So how do we find our work done and heat? Okay, so for here, work done can be found by P times delta V, right? Okay, so according to first law, ideal gas law, PV equals to nRT. Am I right? So if P constant, change in V equals to nR. N and R is always constant, so also nR delta T. So in other words, work done can also be found by nR delta T. Okay, so in this case, because pressure is not given, volume is not given, but what is given? The temperature is given. So we can use W equals to nR delta T. So in this case, look at the process. 3 to 1, so final minus initial T1 minus T3. Values of your N is 1 mole. R is constant at 0.31. So T1, which is 300, minus T3, 455. Negative 1288. Okay. So once we have already found our W, can we find Q? Cannot, from first law of thermodynamics, delta U equals to Q minus W. So negative 1932 equals to Q minus negative 1288. Oh. So Q equals to negative 3220. Okay, so we have already completed all the table. Now let's look at the final one. So the final one, this is a closed loop, or is actually a cyclic process. So since for cyclic process, yeah, the temperature it start at 0.1 and end at 0.1. So meaning that the temperature, the initial temperature and the final temperature will be the same. So by right, your total change in energy, where you sum all of them together, so how much you will get for this? You will get 0, right? Because the temperature, initial and the final temperature are the same. How about work done? Will you get 0 also? Can you try to look for the answer? What is your W and what is your Q? And you can write inside. Okay, yeah, correct. Both of them 519. Okay, so only delta U will give you a total of 0. Okay, when it is cyclic process. But the work done and heat, no, because work done depends on the pathways. Huh? Okay, so move on to next questions. Given if the initial pressure at point 1, this is P1, which is 1 atm. So what are the volume and pressure at point 2 and 3? So we have to look for what is V2 and V3. So there are actually 3 methods for you to solve. You can use the PV equals to nRT to solve them one by one, or you could use the ratio to help you. Okay, so let's extract our information for all the 3 points. So we have T1, P1, we find, and given P1 also equals to P2. So let's use ideal gas law to help us to find this. PV equals to nRT. So for point 2, okay, P2 is 1 atm, so 1.01 3 times 10 to the power of 5. V2 is our unknown, 1 mole at 0.31, T2 600. So another method that you can look for is by using P1 not equals to P2, or P1 is actually equals to P3 because this is isobaric. Isobaric is at process 3 to 1. So P1 equals to P3. We cannot use this for condition 2, but we can use this for condition 3, right? The situation 3. To look for what is our PV3, okay? So another one is, remember you can use the ratio P1 V1 over T1 equals to P2 V2 over T2. So maybe start from 1 to 2 first. So since process 1 to 2, it is isochoric process, meaning that V1 equals to V2. Okay. So these two can be cancelled off. So left only P1 over T1 equals to P2 over T2. So we have the values of P1. So we can look for what is P2, yeah? Divide by T1, which is 300. T2, 600. Okay, so can you try to look for these values? One, not only V2 and V3, also P2 and P3. So using these two methods, and look for all the values for P2, P3, V2, and V3. Okay. And you show your working inside. Okay, so you can intermix after P2. Perhaps you can use ideal gas law to help you to look for V. Or if you want, you can use internal energy to help you also. No fixed method, but as long as if the concept is correct, then you can use any formula that you want. Anyone try to look for P3? So can you find all the values? So basically you can use either ideal gas law, you can use the ratio, or you can actually use internal energy. Okay, as long as if this is an ideal gas, huh? Because even this one is derived from ideal gas law, and this is your ideal gas equation. So this one 3/2 nRT equals to 3/2 PV, also from ideal gas equation. Huh? So you can try with these three. No fixed uh no fixed one to be used. Huh? So it's best on your own convenience. Okay. If not, then let's take a break for 5 minutes before we move on to the summary session. Huh? If possible, please try to solve the questions by your own. Okay, so can we continue? So now let's look at your summary notes. So the study of thermodynamics is actually a study about the equations of the states. So states refers to pressure, volume, and temperature of any process. Okay, so for example, when you are baking cake, so the states of the process, like what is the temperature? Oh, sometimes you need to, there have to be some pressure so for it to cook faster. All right, and how much volume inside the system itself also will affect all your conditions of baking. So this is what we call about thermodynamics, a study about the states of the processes. So there are three laws that related with these states: Boyle's law, Charles' law, and Gay-Lussac law. So it says that when temperature is constant, your volume is inversely proportional with pressure, meaning that the higher the pressure, the lower is the volume. All right. So just imagine, okay, when you make your space smaller, okay, the particles inside the system tends to collide more on the wall. So isn't it means that the pressure is higher? Okay. So secondly, Charles' law says that when the pressure is constant, your volume is directly proportional with temperature. Volume is constant. So when you heat up something, so it actually tends to expand, right? Because your pressure is now constant, meaning that you have to ensure that the collision between the particle and the wall is not being increased. So what to do? You have to increase the volume. Okay, when temperature increases, particle move faster, right? Okay, so by right, if the volume is held constant, then your pressure should increase. Okay, but in this case, because volume is now being increased, so it actually compensate the increase in volume, compensate the frequency of collision. Okay, and as for Gay-Lussac, it says that when volume is held constant, pressure is directly proportional with temperature. Okay, so imagine the same volume, the volume is being fixed. So you heat up the system, particle inside being agitated, so move faster, collides on the wall more frequent, so result in higher in pressure. Okay, so these are the three laws. So when you combine these three together and we get one ideal gas equation, PV equals to nRT. So P stands for pressure, SI unit in Pascal. V stands for volume, SI unit meter cube. So this is very important. Temperature stands for, T stands for temperature, SI unit in Kelvin, not degrees Celsius. So remember to convert to Kelvin. Small capital N is number of mole, R is gas constant. Okay, so why is it very important to convert to SI unit? Because if you look at the unit for your gas constant, it is in Kelvin also. So if your unit is not correct, then you won't get the correct values. Yeah. Okay, so ideal gas law can also be written as in PV equals to NKT. So now this N is big capital N, which is equivalent to number of molecule. Okay, small capital K here is your Boltzmann constant, and T is the same. Okay, so number of molecule is equals to number of mole. This one is number of mole times Avogadro number. Okay, so Avogadro number means we have 6.02 times 10 to the power of 23 particles in 1 mole, meaning that when we talk about 1 mole of, let's say, oxygen, it actually contains 6.02 times 10 to the power of -3 molecules of oxygen. All right? So that is about ideal gas law, and this is what you have to know. Move on to kinetic theory. So there are 5 assumptions for kinetic theories, which you have memorized yesterday. Okay, I think. So 5 of them They move in random motion and random speed. Their motions are all random. And the size is very, very small as compared to the volume of the whole gas. Okay, the size of the particle is very small as compared to the distance between the particle. So meaning that if you put into a big picture, means the size of the particle is very small as compared to the volume itself. So no forces in between the particles except during collision. And even though there is collision, it is perfectly elastic collision. And finally, the molecules are all identical, meaning that the gas type must be the same. And then the kinetic theory of particle, this is when you have a bar on top, means this is the average. So the average kinetic energy of particle is given by half mv squared. So bar here shows that these are all average values. And it's also equals to 3/2 kT. Okay? So K is Boltzmann constant, T is your temperature. So when you further derive, the RMS speed of each particle is given by root mean square 3 kT/m. And this m, remember, it is in AMU, which is atomic mass unit. So this 1 AMU is equals to 1.66 times 10 to the power of negative 27 kg. Okay. So second part of the topic is first law of thermodynamics. So first law of thermodynamics involves internal energy given by symbol U, formula 3/2 nRT. And if it is ideal gas, nRT also equals to PV, and it's also equals to nKT. So first law of thermodynamics says that the change in internal energy, this delta means change. Change in internal energy equals to Q minus W. So what is Q? Q is thermal energy or heat. W is work done. So since U equals to 3/2 nRT, right? So we said delta U means change in internal energy. So meaning that is U final minus U initial. So expand the equation, which is 3/2 nRT. So this T will be the T final minus 3/2 nRT initial. Okay. So that's why we could also conclude that delta U also equals to 3/2 nR delta T. So if we want to write for others expressions, also 3/2 delta PV. Okay. So for first law of thermodynamics, there are sign convention which you have to or you must remember. Okay. So for each of the symbol delta U, if it is positive, means there is an increase of internal energy. So when there is an increase of internal energy, meaning temperature increases. Negative means temperature decreases. As for Q, positive means heat absorbed by the gas. Okay, by the system. Now the system is the gas, means heat absorbed by the gas. Negative means heat released. Okay, or heat loss. And finally, work done. So if it is positive, means work done by the gas, so it is expansion. Negative means work done on the gas, so it is a compression. So these are the sign convention that you must remember. And move on to the 4 types of thermal processes: isobaric, isochoric, isothermal, and adiabatic. So these 3 iso refers to the to each state. Isobaric means constant pressure. Isochoric refers to volume, constant volume, and isothermal refers to temperature, constant temperature. Okay, so the prediction on the first law of thermodynamics due to all these processes. Okay, so isobaric delta U still equals to Q minus W, but your work done is straight away P times delta V. All right, so your ideal gas law, the ratio will becomes only V1 over T1 equals to V2 over T2 here, yeah? So for isochoric, when delta V is constant, it will cause your work done equals to 0. So that's why delta U only equals to Q. Okay, so the work done equals to 0. And during isothermal, so for isothermal, delta T equals to 0, meaning that no change in delta U. So that's why Q equals to W. And if you look at the work done for both isothermal and adiabatic, it's not P delta V only. However, it's the integration. Okay, so this integration, you won't be asked to do integration, but for integration, if based on your knowledge in mathematics, if you have a graph, P versus V, right? So let's say if this is your graph. So the integration of P delta dV, right? From, let's say from this point to this point, from V1 to V2. It actually also means the area under the graph, am I right? Huh? When what you learn about integration. Okay, so since we are plotting graph P versus PV graph, so for process such as isothermal and adiabatic, all right, if you want to find the work done, you have to use integration method. Or another way, you could find the area under the graph. Okay, so both of them is using the same method, using the area under the graph. And we will look at this example later, okay, in the questions. And your ideal gas law, since T is constant, so P1 V1 equals to P2 V2. So adiabatic means no heat exchange. So Q equals to 0, so delta U equals to negative W. So since it is not related with any state, so your ideal gas law is the full one, P1 V1 over T1 equals to P2 V2 over T2. All right. So now let's look at the example. So this example, we will be utilizing the area under the graph. So number of moles 0.2, initial temperature, which is 40, and volume of 2 liter. So initial 2 liter is 0.8. So let's put this as TA, and volume VA 2 liter. Expanding isobarically at a constant pressure of 2.5 times 10 to the power of 5. So this is PA and also PV. So 5 liter, so that will be our VV. Then cool down to at constant volume to pressure 1.2 times 10 to the power of 5, so PC. So VB also equals to VC. Then back to the original state. So the graph is a better illustration of these A, B to C. So work done in the process A, B. So work done can be found A to B. This is isobaric process, right? So isobaric, your work done equals to P delta V. So write down the process. Work done from A to B. So pressure must be the pressure from A to B, and delta V from A to B. So as meant, final minus initial, so VV minus VA. So pressure at point point A or B are the same. So 2.5 times 10 to the power of 5. BB, which is 5 liter, convert to SI unit times 10 to the power of -3. BA is 2 liter. Cannot see that. Very small. So 2 liter times 10 to the power of -3. 750 joule. Okay, so this is by using formula. And remember, I said about it actually can also be equivalent to the area under the graph, right? So let's try to see whether or not area under the graph is applicable here. The work done by process AB. So this is the area covered by line AB, which is a rectangle. So this rectangle, vertical 2.5 times 10 to the power of 5. The horizontal 3 times 10 to the power of -3. Over to SI unit. And we get 750 joule also. So how do we know whether it is an expansion or compression? Look at the arrow. So from A to B, it's moving to the right, which means volume expanding. So this is an expansion. Because your graph from A to B, the directions is moving to the right. Now question 2, the amount of heat absorbed from A to B. Okay, so in order to find the values of Q, there is only one equation in your syllabus, which is first law of thermodynamics. Delta U equals to Q minus W. Okay, so we already found this is from A to B, A to B. We have already found our W. So we need to find delta U. So delta U from A to B equals to 3 over 2 and R delta T, also from A to B. So in this case, since temperature is not given, so we use PV. Assume this is ideal gas. So expand them. Final minus initial, so PV VV minus 3 over 2 PA VA. So once you have found delta U, then plug Replace the values into first law of thermodynamics to look for your Q. Okay, so question 3. Look for work done from C to A. So C to A is a diagonal line up, and C to A is not isobaric, so it's other than isobaric, also not isochoric. So you have to use area under the graph to help you with this. So this is the area under CA. It is actually a trapezium. So trapezium. Two. So the base plus the top times the height divided by 2. $555 for the work done. Any questions? If no, there are actually two Kahoots. One is about ideal gas law and one is about first law of thermodynamics. So quick see which part you are better at. So ideal gas law first. I will show the question on your screen so that it's easier for you to check. Okay. The link will be sent on over the chat. And for those face-to-face, you can scan the QR code also. Or join with your browser www.kahoot.it with the pin 5700859. ready? Already, huh? Okay, so let's start now. They both showing ideal gas law, PV equals to nRT or PV equals to nKT. Very good. No sound, no. True or false, huh? Okay, volume constant, pressure directly proportional with temperature. Yeah, PV from your PV equals to nRT. Okay, from your PV equals to nRT, when your V is constant, so comparing P and T, an increase in an increase in T, what will happen to P? P also increases, right? So that's why they are directly proportional. Okay. Next, how does pressure related with volume? When temperature is held constant. Okay, inversely proportional. Also from PV equals to nRT. Temperature now constant, so meaning on the right hand side is a constant value. So an increase in T will cause a decrease in V. So that this equation only correct, right? Oh, so they are inversely proportional. Now how about volume and temperature? Very good, directly proportional. Also from PV equals to nRT. P, if it is constant, V and T, they are directly proportional. Very good. So which equation represents first law? First law is delta U equals to Q minus W. PV equals nRT is ideal gas law. Okay, so this is the what we call as like ice breaking only, huh? Now, how about the next one? Now of thermodynamics, yeah? Wait. Where's my book? Another 5 questions for first law. Mm. So I will provide another link. So far. And for those face-to-face, join with the QR code. Kaiser, just now was the Kaiser. Now go to the fancy. Get ready? Let's see if you can perform better as compared to previous one. So this is a sign convention when gas is compressed. Compressed means work done on the gas. On the gas is not doing anything. So it is, the sign compression is negative. Positive when it is expansion. Okay, next. When heat is released from the system to surrounding. So Q is heat released. Heat negative, because now why? Your heat is released to the surrounding. Just like your bank account, your money is going out, so negative, right? If you accept money, accept heat, then only positive. Yeah. Okay, very good. When talk about money, everyone understand. Question 3. Which condition will result in delta U equals to 0? Okay, delta U equals to 0 because no change in temperature. So which condition or which process shows no change in temperature? Isothermal. Remember the T here? T stands for temperature. Iso means same T. So temperature is the same. Adiabatic is Q equals to 0. So it won't cause delta U equals to 0. Okay. Okay, isothermal process, delta T equals to 0. Okay, Q not equals to 0, yeah? So how does the volume of the gas relate with the temperature under isobaric condition? Yes, directly proportional. Isobaric means P is held constant, your P is constant. So PV equals to nRT when P constant, V is directly proportional with T. Not bad. Okay. Just now also Lala, huh? Okay, so what I want you to do now, you can have a break, but before break, I need to assign you some work to do. So you go to your folder. Under topic 4, you will see a millionaire, right? So click on the millionaire and answer the questions. There are overall a total of 15 questions inside. So this millionaire is not the millionaire that you play on board game, but those that if you manage to score all 15 questions correct in one row, then only you can win the money. So let's see who is the first to be the millionaire. How many thousands? 150,000, is it? Okay, so you could discuss in the group. And for those online, sorry, you have to do by your own. Okay, but for those face to face, you can discuss together. Okay, so just to show you, okay, so when you click inside there, I think you can ask for help 3 or 4 times. Yeah? Okay, so they will help you. Okay, but once if you score one question wrong, then you have to restart. All right, but don't give up because this will actually help you to get familiarized with the questions more. Okay, so once you are familiarized with, okay, let me show you here. So under your model, this is my model, not your model. So click on this millionaire. So you can answer. So on top of here, the phone, the people, and the cross sign. So this one can help you to eliminate the possible wrong answer. But sometimes when you ask the opinion from people, sometimes it will give you the correct answer, but sometimes not. So you have to make your justification by your own, huh? So a total of yes 150,000 if you can answer 15 questions correct in a row. Okay, so I can actually check your progress here. So I just want to show you. Huh? Hey, Brendan, so fast. Yeah, I just want to show you. Like when you see how seniors they do their work, right? Some people they actually attempt for a lot of times before they manage to score full mark. So if you look at them, less than 10 times or 20 times. Oh. So just want to tell you when you do your work, right? Sometimes you keep on like stuck on question 2 or question 3. Don't give up because as long as you never give up, you will still get the we call the virtual money or muda. Okay, So I'll give you how long you need? 30, 40 minutes to try. Okay, including the rest time. So you can take your own sweet time. You can go to uh, the toilet or eat something while trying. Okay, so if you have a question, you can always ask me. So 40 minutes at 3 o'clock, we will discuss the answer. I will share the link for Jamboard later also for you to share your answer. Sharing is caring, huh? So who knows your working will enlighten your classmate, the other people, on how to work on this question. Okay, so let's look at the question. Okay, question 1. So determine the volume. Okay, yes. So we have like ideal gas, so we could use the ideal gas equation, TB equals to nRT. And P is at 1 atm. What atm have to convert to SI unit, convert to Pascal. So 1 atm unit conversion is 1 times 1.01 times 10 to the power of 5. This one is converted to Pascal. Volume is what you need to find, given that 1 mole of gas, R is your gas constant, T in Kelvin, so 0.0224 meter cube. Very good. Question 2. Helium balloon is a sphere, has a radius of 18 centimeter, temperature given at 20 degrees Celsius. And let's say the internal pressure, means this is pressure, is 1.05 atm. So find the number of mole, find N, and also the mass of the helium gas. Okay, so in order to find the number of mole, use ideal gas law, so which is N here. So we have to find PV and RT. R is constant, so P given as 1.05, yes, convert to SI unit. Temperature 20 degrees Celsius, yes, in Kelvin, very important. Temperature, SI unit for temperature in Kelvin. And volume, radius of the balloon is given, so yes, volume is the volume of the sphere, very good. 4/3 pi r cube. And centimeter convert to SI unit, which is 0.18. This one is in meter. Okay, so 1.06. Okay, and finding the mass, so using your molar mass, okay, 4.26. So find the nearest one. The assumption is different because in here it is using 1.013 times 10 to the power of 5. And to the conversion to Kelvin is 273.15, but it's okay. Okay, around that. Third questions. Okay, this one is the same as your lecture notes, but now you're asked to find, okay, this one add in, what is the gauge pressure? Let's follow the one on the. Okay, so what is the gauge pressure within the target? Okay, so given at 10 degrees Celsius, your P1 is 210 kilo. Okay, and at temperature 2, which is 40 degrees Celsius, final temperature. The working correct. Okay, so this working is not acceptable. Okay, so remember when using ideal gas law, okay, your P must be absolute pressure. So at this place here, your 210K, this is gauge pressure. So if you put inside here, then this is wrong. In here, you get only 233. So basically, this is not correct, huh? But because when you look at here, this is the nearest value. But how to actually solve this? Remember, it must be absolute pressure. So when it comes to absolute pressure, what you have to do? You have to plus the gauge pressure with the atmospheric pressure, right? So 210, atmospheric pressure 101.3 K. One zero one K plus 12. Okay. Then from here, your P final is around 344 kilopascal. So what is the gauge pressure at final? So 344 K minus 101 K. This is how you get 243 K. Okay, so please be careful. So it's good that now you show it here, then I can correct in time. But better than you show this during exam and you don't know why you are wrong. Okay. Now question 4, find the RMS speed. So RMS speed equals to root square 3K over M. So this M is in AMU unit. So have to times the AMU. So K is Boltzmann constant 1.38 times 10 to the power of negative 23. Huh? So T has to be in Kelvin, very good. Divide by, now the mass for one hydrogen is 1 gram, right? 1 U. So now you have H2, so it's basically equals to 2U. So 2U, U is 1.66 times 10 to the power of negative 27. Huh? So it's around 2.16 times 10 to the power of 3. Very good. Now, when a gas is heated at constant pressure, heat supply is 2. Okay, so this is Charles' law. Okay. PV equals to nRT. When this is constant, heat supply increase in T will cause an increase in V. So A correct. Okay, according to Charles' law also. Number 6. What is reversible thermodynamic processes? So just like your chemical reaction, if let's say substance A plus substance B produce substance C. So if it is reversible, means C can also reverse back to being derived back to A and B also. So just the pathway of the process is reversible. Same to the thermodynamic processes. And question 7. 800 joule of work is done by, so done by, yes, work done is positive. Internal energy reduced, so this is negative. Find the amount of heat. So by first law of thermodynamics, delta U equals to Q minus W. Put in the value with the sign convention, so negative 600 equals to Q minus, work done is positive, so 800. So Q is 200. Very good. Okay, this here is a difficult here. Okay, and question 8. Find the heat supply for the process. So you have to find the Q. So finding Q from first law of thermodynamics. Delta U equals to Q minus W. So how to find delta U? So in this questions, you are given with both PV and also temperature. Okay, so you can choose to use you can choose to use PV or you can choose to use and our delta T also can, huh? Okay, so here the example given is by PV. Since P is constant at 0.31, so change in V is 0.7. Okay, equals to Q and no work done because this is an isochoric process, so around 873. Or if you want to use 3/2 and our delta T also can, so 3/2. Number of mole is 1, R is at 0.31. Delta T is change in temperature, so 100 minus 20, which is 70. So even though if you convert to SI unit in Kelvin, 100 SI unit in Kelvin is 373 Kelvin minus 303 also equals to 70. Okay. Question 9. So gas of pressure. This is P1 and volume 1 V1 heated at constant pressure until volume. So constant pressure means P1 equals to P2 and V2 is 0.04. Then the gas is heated at constant volume means you still have another stage 3. So V2 equals to V3 until final pressure, which is P3 equals to 3.5 times 10 to the power of 5. So what is the total work done? Okay, so you could use the formula or you can actually use the graph to help you to better illustrate this process. So given, firstly, constant pressure. So from 1 to 2 is constant pressure. And 2 to 3 is constant volume. So meaning that the only work done will be under 1 to 2. So work done is from 1 to 2. So your pressure at point 1 and 2 is 2 times 10 to the power of 5. Change in volume from point 1 to 2 is from 0.04 minus 0.02. Yes, so 4,000 joules. Question 10. Adiabatic expansion. So adiabatic expansion means no transfer of thermal energy, Q equals to 0. 11. So there are two pathways, ADC and ABC, starting from A and end at C. 80 joule of heat is absorbed and 50 joule of work done by half ABC. So this is Q ABC and this is WABC. Both are positive. The sign convention for both are positive. And as for ADC, 60, the work done of ADC is 60. Find the change in energy or find find the heat of find the change in energy for pathway ABC. So finding the heat of ABC. So since it starts at A and ends at C, means the total change in internal energy from A to C will be the same. Okay. So delta U from ABC equals to delta U of ABC. So from the information that you have for ABC, delta U is equals to 30. So ABC also equals to 30. So you could find that your Q is equals to positive 90. Positive from the sign conventions means heat is absorbed by the gas. So 90 joule of heat absorbed by gas from pathway ABC. Question 12. 0.5 mole. So initial temperature, this is TA at 300 degrees Celsius. Final TC at 40 degrees Celsius. Even heat removed. So heat removed means negative sign convention, negative Q, 1520. So find the final volume at C. So in order to find the volume, we need work done. So how do we find the work done? From first law of thermodynamics, because Q is given. So started off with first law, delta U equals to Q minus W. So this is referring to B to C. Okay, so what we have here, we have only TA and TC. All right, so we have to find delta U first from point A to C, straight away from A to C, because we have only these 2 points. So 3 over 2 R delta T. So delta T here, since it is from A to C, so TC minus A. So delta U is negative 1620 joule. So once we have found AC equals to Q AC. Okay, so this is also QAC minus WAC. Okay, work done from A to C also equivalent to work done from B to C, because no work done from A to B. So put in the values with the sign convention. Work done is around 100 joule. So work done equals to P delta P. So this one is equivalent to work done from BC only. So work done, pressure given as 1.0 times 10 to the power of 5. Volume, final minus initial. So final will be BC, initial will be VB. So B final is what you need to find at point C. So 1.3 times 10 to the power of negative 2. Okay. Question 13. Which graph is correct about A and B? So these 2 graphs, they are either isothermal or adiabatic. Or alternatively, you could use this when it is an ideal gas. Very smart. This is the insight that you can provide to your friend. Okay, move on to continue with question 13. So it is either isothermal and adiabatic. So which one is isothermal, which one is adiabatic? The steeper one will be the adiabatic. So if you compare the gradient between A and B, this one is steeper, right? B is steeper. So B is adiabatic, while A is isothermal. So how do we know if it is expansion or compression? Look at the arrow, the direction of arrow. So the directions of arrow shows that the V increases. So that's why both are expansion. Question 14. Find temperature at T. So very straightforward. Since temperature at A is given, PA, you have the values of PA and also VA, so we can compare the ratio. PV over T equals to PV over T. So comparing point A with point B. So T in SI unit, we get 939 Kelvin. Since answer provided, final answer in degrees Celsius, so convert back to degrees Celsius, 666. So now what is at C? So you can also comparing PV over T. So also point A straight away with point C. And you get, converting to SI unit, 313. So 14 degrees Celsius. Okay? So it's actually based on the calculation. Basically, I would say the thermodynamics is not easy to illustrate because it is not something that we can see from our naked eye. You can't see temperature, you can't see pressure. But if you are inside, you might feel it. Okay? But when it comes to calculation, like what I say, you know you are correct because when you do your calculation, all different methods, correct, you will get to the same answer. Okay? So if your calculation is correct. Any question about today's topic? So this topic is the last topic to be included in your final, your midterm. Your midterm is on next Thursday. So next Thursday, 2 to 4 p.m. The math clinics I exchanged with Ms. Shuba for the clinic session. So your exam will take place next door, SK2, SK3205, next Thursday from 2 to 4 p.m. So for those who register to face, you have to come here and sit on different table. I will be here. And for those online, you must turn on your camera. So if you do not have a camera yet, you might have to borrow one. Okay, just for next week, and you have to turn on your camera. So I will invigilate both face-to-face and online together. Okay, so bring your own paper if you would like to write on paper, and the submission is also through Moodle. All right, but if you like to write on your tablet, is acceptable also. Okay, so whichever is convenient to you. Okay, and we will be having lecture 5 next week also. So I think you have to arrange your time nicely. And also, what else? And get ready with your project. I think your exhibition is next month. Okay. So if no question, then that's all for today. So I will see you tomorrow for clinic. Okay, so the clinic session for physics, because I won't have any revision session for physics. Okay, but all the revision will be covered during clinics. So if you want to have some revision, then you can come for clinics. Otherwise, you can always refer back to videos. I would encourage you to no harms to learn more. Okay, so that's all for today. Bye bye. Thank you. See you.